Okay, let's have a conversation about why we think some people are normal and why we think some people are weird. Okay, these normal people, we have a negative form, or a negative direction, sorry, a weak linear form, but a negative direction, which means as shoe size gets bigger, that means probably taller people, and it takes them less steps to get to the window. But here, we have people where as their shoe size gets larger, for some reason it takes them more steps to get down the hallway. Well, people walk differently. So last year when I had this data, I did have people that didn't go along with the form. And so I broke them down this way so that you could see a positive association as well as a negative association. Now, for the normal people, I have a mean x bar of 9, a standard deviation s sub x of 0.8. This would be y bar, and this would be s sub y. Okay, I think these make sense to you right here as x bar and s sub x. Now, we're going to find the correlation. I need two long lines. You guys write small on this. Just trust me, write small. There are 1, 2, 3, 4, 5 data values. So r is going to be equal to 1 over 4. 1 over n minus 1 is 1 over 5 minus 1 is 4. Now I'm going to put a big giant bracket here. And here we go. For the point 8 comma 63, I'm going to have 8 minus the mean of 9 over the standard deviation of 0.8. That's 8 minus the mean over the standard deviation. Then it's times the 63 z-score. So I go 63 minus the mean, 61.6, and it'll be over the standard deviation of the y's 1.8. Okay, once you write this out once, it'll start to, you'll pick up a pattern, okay? The second one is, I'll just put a check. We already did that point. The point is 1060. So here we go. I go 10 minus the mean of the x's, 9, over the standard deviation, 0.8, parentheses. The second set of parentheses is for that 60, the x value. So I go 60 minus 61.6. I'm writing smaller because I'm worried I'm going to run out of room. That's going to be over the 1.8, the standard deviation for the y's. The third one, it's the point, I'll put a check above the second one, 9 and 64. So I go 9 minus 9 over 0.8. I could stop writing right now because I know this whole little section is going to be 0. But anyway, the y value is 64, so I go 64 minus 61.6 over the 1.8. That was a waste of time. This whole thing is going to be 0. Anyway, the fourth product of z-scores is going to be this 9.5 and 61. So I go 9.5 minus 9 over 0.8. And then I also have 61 minus 61.6 over 1.8. And my last one, which I barely have enough room for, will be 8.5 and 60. So I go 8.5 minus 9 over 0.8. I'm going to try and sneak this in on the end of the page here. 60 minus 61.6. Made it. Over 1.8 parentheses. Okay, I need a big bracket thing, so I'm going to make a big bracket thing too. There we go. It all fits on the page. Okay, so how do you get all that in the calculator? You can, I think you're going to have to use some parentheses here. Let me show you what I'm going to do. Okay, I'm going to clear everything I have. I have 8 minus 9 over 0.8 and 63 minus 61.6 over 1.8. I think I'm going to find out what that is first. So I'll be rounding in the middle of the problem, which leads to some round off error, but we'll be pretty close. I don't think anybody wants to put all of this in the calculator and be guaranteed that you get it right. Okay, so watch. Parentheses, 8 minus 9, parentheses, divided by 0.8. I can keep going. Times, parentheses, 63 minus 61.6, parentheses, divided by 1.8. If you just type in this divided by this times this divided by this, the order of operations tells you that we're good to go. So that stuff put together is negative 0.972. So I'm going to go down here and I'm going to write 1/4 times a big bracket. This whole little section here ended up being negative 0.972. I'm going to put a plus. Then we're going to do it again with these here. So to my calculator, parentheses, 10 minus 9, parentheses, divided by 0.8 times, parentheses, 60 minus 61.6, close those parentheses, divide by 1.8. I hit enter, and I get negative 1.1 repeating. So I'm going to say negative 1.111. I'll go 3 decimal places for all of them. We'll just do that. Okay, and then the third one. Whoops, I don't have to do anything there. That's a fat 0 right there. So plus. Then we go to parentheses. 9.5 minus 9, close the parentheses, divided by 0.8 times, parentheses, 61 minus 61.6, close those parentheses, divide by 1.8. Hit enter and I get negative 0.208 if I go 3 decimal places. And I got one more. The last section, which I wrote real small, goes 8.5, oops, yeah, I have parentheses, minus 9, make sure the whole thing is in parentheses, divide by 0.8 times, open up the last set of parentheses, 60 minus 61.6, close the parentheses, divide by 1.8, and that one is 0.5 repeating, so I'm going to call it 0.556. Okay, so put these in the calculator, divide by 4, and we get correlation. Negative 0.972 plus negative 1.111 plus 0 plus negative 0.208 and then plus 0.556. I end up with 1.735, but I haven't divided by 4 yet, so I'm going to hit divide by 4 and I get negative 0.43. We'll go 4 decimal places for correlation here. Negative 0.4338. R equals negative 0.4338. Now guys, you already know this. Correlation tells you two things. It tells you the direction of the scatter plot, it's negative. It tells you how strong it is. It's closer to 0 than it is to 1, so it's on the weak side. Now let's go look at that scatter plot. It's definitely negative, and it's definitely not very strong. So R equaling negative 0.4338 should actually make sense for that scatter plot. Okay, here's what I want you to do. You see it coming. Find the correlation for this one. It should be positive, and just by looking at it, might be a little bit stronger. All right, go find your correlation.